On the previous video, I have tackled ZTest for one sample group. On this video, I will discuss ZTest for two sample mean tests. What is ZTest for two sample mean tests? The Z-test for two sample mean tests is another parametric test used to compare the means of two independent groups of samples drawn from a normal population if there are more than 30 samples for every group. When do we use Z-test for two sample mean? We use it when we compare the means of samples of independent groups taken from a normal population. Why do we use the Z-test? We use the Z-test to find out if there is a significant difference between two populations by only comparing the sample mean of the population. How do we use Z-test for a two sample mean test? We use the formula Z is equal to x sub 1 bar minus x sub 2 bar all over the square root of s sub 1 squared all over n sub 1 plus s sub 2 squared all over n sub 2, where x sub 1 bar is the mean of sample 1 and x sub 2 bar is the mean of sample 2. S sub 1 squared is the variance of sample 1 and S sub 2 squared is the variance of sample 2. Note, if the given is a variance, there is no need for us to square it. However, if the given is a standard deviation, then square it for it to become a variance. Then, n sub 1 is the size of sample 1 and n sub 2 is the size of sample 2. For example, an admission test was administered to incoming freshmen in the College of Medical Laboratory and Sciences and College of Radiologic Technology with 100 students, each college randomly selected. The mean scores of the given samples were 90 and 85, and the variances of the test scores were 40 and 35 respectively. Is there a significant difference between the two groups? Use 0.01 level of significance. Solving by stepwise method, first is to identify the problem. Is there a significant difference between the two groups? Then, formulate the hypothesis. For the null hypothesis, there is no significant difference between the two groups. Symbolically, we can denote it as x sub 1 bar, or that is the mean of group 1, is equal to x sub 2 bar, or that is the mean of group 2. So they are equal because there is no significant difference between them. And for the alternative hypothesis, there is a significant difference between the two groups. Or we can denote it as x sub 1 bar is not equal to x sub 2 bar. So they are not equal because they do possess a significant difference. Notice from our alternative hypothesis that this is a non-directional test, meaning to say, we'll be using a two-tailed test. X will be the level of significance. So, for our alpha, we'll be using at 0.01. For the z tabular value, we'll be using a level of significance of 0.01 and a two-tailed test. Then get their intersection, that is positive negative 2.575. Then solving now by Z-test for two sample means. First, let us identify the given values. So the mean of group 1 is equal to 90 and mean of group 2 is equal to 85. Then, the variance of group 1 is 40 and the variance of group 2 is 35. For the sample size, group 1 and group 2 have both 100 as sample size. Then plug in these values into the formula. So that is now 90 minus 85 all over the square root of 40 all over 100 plus 35 all over 100. Then simplify. 90 minus 85 is equal to 5. Then 40 all over 100 plus 35 all over 100, that is 75 all over 100. Then simplify further. So 75 all over 100 is equal to 0.75. So that is now 5 divided by the square root of 0.75, which is 0.866. So the Z computed value is equal to 5.774. Then, for the decision rule, if the Z computed value is greater than or beyond the Z tabular value, this confirm HO. So let us plot those values into the graph. So we have here the graph. The Z tabular value of positive 2.575, that is located on the right side of the graph because that is positive. Then on the rightmost part is the Z computed value of 5.774. From this itself, the Z computed value goes beyond the Z tabular value. Therefore, this confirmed the null hypothesis. For the conclusion, since the Z computed value of 5.774 is greater than the Z tabular value of 2.575 at 0.01 level of significance, the alternative hypothesis is confirmed, which means that there is a significant difference between the two groups. It implies that the incoming freshmen of the College of Medical Laboratory and Sciences are better than the incoming freshmen of the College of Radiologic Technology. That is the Z-test for two sample mean tests. Thank you for watching and I hope you have learned something.